Everyone, and welcome to our educational session. My name is Paul Arsov, and I'm the founder of the Decentralized Web project. The topic of our educational session today is the nature of knowledge with its consistency and coherence applied to get good AI. The topic touches on psychology and also technology, and it relates to the currently leading wave of technology, which relates with artificial intelligence. So in the beginning, we're going to take a look at a book published by physicist David Deutsch, which is called The Beginning of Infinity, a book that ambiguously tackled the nature of knowledge, progress, and explanation. Among the many insights, one idea stands out for its deceptive simplicity. Good explanation is hard to vary. That is, a powerful explanation cannot be arbitrarily tweaked without unraveling its coherence or contradicting the facts it seeks to illuminate. This principle, elegant in its clarity, carries profound implications, not only for science and philosophy, but for the future of artificial intelligence. At a time when AI systems are increasingly tasked with reasoning, decision making, and even explaining their conclusions, a Deutsch criterion offers a litmus test for quality. It also reveals why creating a high quality reasoning AI that lacks coherence with facts and logic is not just difficult but fundamentally impossible. So at its core, the book of Deutsch and his criterion is about constraints. A good explanation, he argues, is tightly bound to the evidence and the internal logic that supports it. Consider Einstein's theory of relativity, a paragon of explanatory power. Its predictions, such as the bending of light by gravity or the dilation of time at high speeds, are not arbitrary. They flow inescapably from the theory, math structure, and its alignment with empirical observations. If you were to alter a fundamental premise, such as the constancy of the speed of light, the entire edifice would collapse. The theory is hard to vary because its components are interdependent, constrained by both logic and facts. Contrast this with pseudo-scientific claims such as those in astrology. Astrological predictions can be endlessly modified to fit new evidence. If a horoscope fails to predict an event, its proponent might tweak the interpretation of a planet's position or invent a new astrological rule. Such explanations are easy to vary because they lack rigorous constraints. They can bend, twist, and shift without losing their superficial plausibility. But in doing so, they forfeit genuine explanatory power. They explain everything and therefore nothing. This distinction matters because it reveals what makes explanations trustworthy. A hard-to-vary explanation is robust, testable, and predictable. It demands consistency with facts and logic, making it fragile in the face of arbitrary changes. This fragility is not a flaw, but a feature. It ensures that the explanation is tethered to truth. And now consider the burgeoning field of artificial intelligence, particularly system designed for reasoning. A high-quality reasoning AI aims to generate conclusions that mirror the rigor of good explanations. Its outputs should be hard to vary, rooted in specific facts, and valid logical steps, such that altering a premise or inference rule would invalidate or render incoherent its conclusions. This is not a mere technical aspiration, but a definitional requirement. Reasoning, by its nature, demands coherence with facts and logic. Without it, the system ceases to reason and begins to confabulate. Imagine an AI tasked with diagnosing medical conditions. A high-quality system would base its diagnosis on biological facts, system patterns, lab results, known disease mechanisms, and follow medical inference rules. If you were to arbitrarily change a key fact, say altering a patient's test result, or modify its reasoning process, say ignoring causality, the diagnosis should break. This fragility ensures that the AI conclusions are not capricious but necessarily tied to the truth. Conversely, an AI that lacks coherence with facts and logic produces outputs that are easy to vary. Its conclusions can be reshaped or contradicted without consequence, much like the malleable claims of pseudo-science. For instance, if the AI diagnoses a patient with a disease based on irrelevant data, say the patient's birth date, or illogical reasoning, say assuming symptoms always indicate the most common condition, its outputs can be endlessly modified to fit new information. Such a system might seem superficially plausible, but it lacks explanatory power. It fails to clarify underlying principles or causal relationships, rendering its conclusions unreliable and untrustworthy. The statement, nobody knows how to create a high-quality reasoning AI that lacks coherence with facts and logic, is not a confession of ignorance, but recognition of impossibility. Coherence with facts and logic is not an optional feature of high-quality reasoning. It is its essence. Attempting to design a reasoning system that disregards factual correctness or logical rigor is akin to trying to build a bridge without adhering to the laws of physics. The structure would eventually collapse under its own weight and contradictions. This impossibility stems from the structural constraint imposed by good reasoning. First, the system's explanations must fit the empirical data. Arbitrary changes to these facts, say altering a patient's symptoms or misrepresenting a data set, should lead to contradictions. And second, the reasoning must adhere to a valid inference rules. Even a small alteration in premises or logic can invalidate the entire argument. These constraints make good explanations resistant to arbitrary tweaks, ensuring that they are hard to find and thus robust, testable, and genuinely explanatory. When AI lacks these constraints, its outputs become malleable in arbitrary ways. Um, Contradictory or ad hoc adjustments can be added freely, and because there is no consistent demand for alignment with reliable reasoning. This is the hallmark of poor explanation. For example, consider an AI that predicts stock prices based on irrelevant data, say weather patterns or illogical reasoning, say assuming correlations implies causation. Its predictions could be endlessly modified to fit new market trends, but they would lack predictive power. Such a system is easy to vary and therefore unreliable. In the rapidly evolving space of artificial intelligence, a pressing question looms large. How can we ensure that AI systems not only deliver accurate results, but also provide explanations that we can trust and understand? This challenge brings us to a fascinating intersection of cutting-edge technology and philosophical insight. Specifically, David Deutsch, hard to vary criterion. A renowned physicist and thinker, Deutsch argues that good explanations possess a unique resilience. They cannot be easily altered without losing their power or introducing inconsistencies. This principle, well rooted in the philosophy of science, offers a profound framework for assessing the quality of reasoning in AI, particularly in the emerging domain of large reasoning models. For years, artificial intelligence has been dominated by so-called black box systems, typified by deep neural networks. These models excel at tasks like image recognition or natural language processing, often achieving uncanny accuracy. Yet their inner workings remain largely opaque. When a neural network identifies a cat in a photo or translates a sentence, it offers no clear account on how it arrived to that conclusion. The path from input to output is a tangle of weight and activations, decipherable only as statistical patterns and not as reasoned steps. This opacity poses a problem when viewed through Deutsch's lens. Without visibility into the decision-making process, we cannot determine whether a black box model output adheres to the hard-to-vary principle or merely reflects clever pattern matching that might falter in unfamiliar contexts. Accuracy alone doesn't guarantee explanatory power. A simple system may be right for the wrong reasons, its conclusions fragile beneath the surface. Even large reasoning models, a new breed of AI designed to prioritize transparency and structural thought. Unlike their black box counterparts, these models emphasize explicit reasoning process. Um, think uh, symbolic logic or a chain of thought approach where each step is articulated and inspectable. Picture an AI that doesn't just state the answer is 42 but shows its work. Given X and applying rule Y, we deduce Z, and this leads to the end result. This openness allows us to evaluate not just the outcome but the reasoning itself. What sets high-quality large reasoning models apart is their commitment to coherence with facts and logic. Here, coherence means two things. First, the model grounds its reasoning in accurate, verifiable data. Second, it adheres to logical rules, ensuring that each inference follows validly from the step before. This creates a tightly knit chain of thoughts, much like a well-crafted argument in a debate. Um, every link depends on the others, anchoring in evidence and reason. This coherence aligns directly with Deutsch's criterion. In a coherent reasoning model, you cannot tweak one step, say swap a fact or skip a logical rule without repercussions. The entire chain would unravel, exposing inconsistencies or errors. For example, if an AI explains a medical diagnosis by tracing symptoms to a disease via established biological principles, altering a symptom or a principle mid-chain would invalidate the conclusion unless the change is systematically justified. The explanation is hard to vary because it is bound by reality and reason. Now consider the opposite, an AI system that lacks coherence, ignoring facts or a logical consistency. Its explanations become malleable, easy to adjust without consequence. If the system is untethered to evidence or valid inference, you could swap out premises, insert contradictions, or patch gaps with ad hoc fixes, and it wouldn't protest because there is no backbone holding it together. This flexibility is the hallmark of weak explanations per Deutsch's standard. Think of conspiracy theory again. When new evidence emerges, proponents can simply tweak the narrative, like the government hid it, becomes the aliens hid it, without a core structure to constrain them. An incoherent AI operates similarly, producing outputs that might seem plausible but lack the depth to withstand scrutiny. Such explanations are easy to vary and thus unreliable. The implications for AI are striking. A high-quality large reasoning model, by definition, must represent the constraints of facts and logic. Its outputs, whether predictions, diagnosis, or analysis, emerge from a process that mirrors the robustness of scientific theories. Change one element arbitrarily and the system's integrity falters, signaling either an error or a need for recalibration. This rigidity isn't a flaw, it is a feature, ensuring that the model's explanations hold explanatory power beyond mere statistical luck. Attempting to build a high-quality reasoning AI that flouts these constraints is frankly nonsensical. An AI that disregards facts and logic would churn out explanations that bend too easily, lacking the internal resistance that Deutsch identifies as essential. It might mimic reasoning superficially, but its outputs would be brittle, unable to stand up to rigorous testing or real-world complexity. Large language models offer a promising vision for AI, machines that don't just compute but reason in ways humans can follow and trust. By embedding transparency and coherency in their designs, these models embody the hard-to-vary principle. They produce explanations that are not only accurate but also resilient, tethered to the reality they describe. As we push the boundaries of artificial intelligence, Deutsch's criterion serves as both a guide and a challenge. It reminds us that true explanatory power isn't about flexibility or convenience, it's about being right for reasons that endure. For AI to rise to that standard, coherence with facts and logic isn't optional, it is the foundation of reasoning worth believing in. And with this said, I'm ending this presentation and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsof and I'm the founder of the Decentralized Web project and several other projects. First, the Decentralized Web project is building a decentralized advertising and communication system. So as I just said, it is monetized through advertising, and the mean of decentralization is different than the meaning put by blockchain technology. In our point of view, we consider blockchain technology as deeply flawed and unsuitable to drive decentralization. In our implementation of decentralization, we rely on direct communication from user to user without going through a third party, namely a server or a central point which collects data from users and then it distributes this data back to the users. Once again, in our implementation, we allow direct communication from user to user. With this said, I like to mention that we have our own blockchain instance, and this blockchain instance has tokens which are used to reward people joining our decentralized communication platform. It also rewards existing users who invite other people to become users on our platform, and it also rewards our users for viewing advertising, which is very permissive. Essentially, there's a screen where you can request viewing advertising, and then you are going to go page by page by clicking for the next page to view the advertising which is presented. It is very permissive, and we believe that is this next wave of responsible advertising, and advertising which actually has an impact because the user is requesting, and they're rewarded for viewing this advertising. With this said, I like to tell you the name and the URL of the website of this project. It is decentralizedweb.org. Decentralized and web, these are two words, and they're typed all together. Decentralized web. And then there's dot and it ends with org. And with this said, I'm going to the second project that we built and released, and this project built marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. With three-dimensional objects, there has to be a special software which loads, which reads the 3D object, then it opens a window, it displays the 3D object, and then it may move this 3D object. In general, the creators of 3D objects, they use game engines, and currently there are two very popular choices for 3D object creators to display their objects. Like one of these game engines is called Unity, and the other one is called Unreal. But from the very beginning of our project, we decided to build our own 3D software engine, and it does the basic things of reading the file, opening a window, displaying the 3D object, and then it starts animating this 3D object in a way of moving it in a random fashion around the window it did open. But in addition to these basic capabilities, the 3D software engine has multiple additional capabilities, and the first additional capability is the capability of speaking. The 3D NFTs can speak in one of three different voices. They can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed fashion, or in a fast speed fashion, or in a slow speed fashion. And if we have a male voice and it is spoken in a slow speed fashion, then this voice can come as the voice of a very masculine person or the voice of an old person. And if we have a female voice and it is spoken in a fast speed fashion, then this voice can come as the voice of a little girl or the voice of a funny person. The next additional important capability is the capability of voice recognition, which is included in our 3D software engine. You can ask the 3D NFT, what is your name? And then the 3D NFT is going to reply with their name. And if you have a 3D NFT as being animated and moving in a random fashion around the window, then you can issue your very first voice command to the 3D NFT to stop moving. and then the 3D NFT is going to stand still and stop moving. You can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands. The next additionally important capability is the capability of the 3D NFTs having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT, who are you? And then the 3D NFT is going to reply with few sentences of, on who they are. You can ask the 3D NFT to describe something, and then the 3D NFT is going to describe, for example, about Web3 or about decentralization or about the country called Russia. And the last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or cyan colors. And then you can come to our 3D NFT marketplace website. And now is the time to tell you the name and the URL of this website. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together. Decentralized web, then there is dot, and it ends with org. Once again, 3D NFT dot decentralizedweb.org. On the top of the main page and every other page, you can see number of links. One of these links points to links to accessories, and when you click on this link, you're going to see that we are offering special glasses. When you click and order one pair of these glasses, then you are going to see that one lens of these glasses is red and the other lens is blue cyan. When you get these glasses, you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you can see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. And with this set, I'm ending talking about our 3D software engine and collection of 3D NFTs, but I like to mention something about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. It runs Ethereum software, and it is the same software which runs on Ethereum mainnet, on Binance Smart Chain, on Polygon Matic Chain, and on Avalanche Avax Chain, and many other famous and not so famous blockchains. In this way, we do not charge our users for paying gas fees for deployments of the smart contracts for the non-fungible tokens, and we do not charge our users gas fees for transactions of transfer of ownership from one user to another user. In addition to this, we allow buying and receiving proceedings from sale in multiple crypto coins. Currently, the choices for purchase and getting proceedings from sale includes 4 different coins, namely Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which has a coin called KCS, and Qcoin is a big centralized crypto exchange. With this said, I like to mention that we have actually a second parallel and independent way of buying and getting proceedings from sale of 3D NFTs, and it is done entirely in fiat currency. So let's say you are a user, you come to our website, you browse through the collection of 3D NFTs, you click on one you like, and then you're going to be presented with a drop-down menu where you can select a choice of payment between 4 different crypto coins and the 5th choice of paying with fiat currency. So let's say you select paying with fiat currency, and then you are going to be presented with a screen where you have to put the number of your debit card or credit card, expiration date, CVC, and when you click to complete this transaction, then the payment is going to be converted from your national fiat currency to US dollars and deposited in our bank account. Then we are going to make a transaction and transfer of ownership from the initial ownership from our marketplace to you, and now you become the user of this 3D NFT. So let's say there's a second user who comes to our 3D NFT marketplace, and you, after a while playing with the 3D NFT, you decide to put this 3D NFT for sale. You decide on the price that you want to put the 3D NFT for sale, and so let's say the second user who came to the 3D NFT marketplace, they browse through the 3D NFTs, and they see and like in particular the 3D NFT that you put for sale. So when they click on this 3D NFT, they're going to be presented with the same screen asking for payment either in 4 different crypto coins, or a 5th choice of paying with fiat currency. So let's say they select payment with fiat currency, then they put their debit or credit card, expiration date, CVC, and when they complete the transaction, there's going to be a transfer and conversion from their national fiat currency, which could be different than your national fiat currency and different than US dollar, and the payment is going to be deposited in our bank account in US dollars. So the next step which we are going to do is we're going to transfer the ownership from you to the second user, and now they become the owner of this 3D NFT. And we are going to follow this with transfer from our bank account and conversion from US dollars to your national fiat currency. And the payment for the sale is going to be deposited in your bank account in your national fiat currency. With this said, I'm ending talking about this second project, and I like to mention the third project that we are working on. And this project is building charging products for electric vehicles. We estimate that the number of electric vehicles currently in operation is going to grow exponentially, and this is going to present a problem for charging these electric vehicles. Currently, charging of such electric vehicles is handled in a way of resembling the parking lot, the gas station model, where the users are coming to the locations with several charging columns, and then when they come, they connect electric cable to their electric vehicle. They identify themselves to the charger. They request starting loading energy. They stay for a while at this location while their car is charging, and then they leave. But we estimate that the number of these charging stations is going to become ultimately insufficient, and what we're proposing and building products for is the parking lot model, where the users, like owners of electric vehicles, which are living in high-rise residential buildings. These buildings are outfitted with a ground floor parking lot or multiple underground floors of parking lot. When the owner of electric vehicle is coming in the evening from work, then they could connect electric cable to their to the kind of a charger that we're building. They could identify themselves to the charger by their debit card, credit card, or near-field communication card, or near-field communication keychain token, or near-field communication ring they could be wearing, and they could request start of charging of their electric vehicle. They could leave their vehicle to charge during the evening, night, and early morning. But in the same way, these owners of electric vehicles, they could be working in high-rise office buildings, and these high-rise office buildings could be outfitted with a ground floor parking lot or multiple underground floors of parking lot. In the same way, when the owner of this electric vehicle is coming in the morning for work, they could connect the cable to their electric vehicle. They could identify themselves to the charger, and they could request start of charging, and they can leave their vehicle to charge during the morning, afternoon, and early evening while they're at work. And with this said, I like to tell you the name and the URL of the website of this project. It is power.rstack.com. Power is the ordinary word for power, then there is dot, then there is a word which I can spell it letter by letter. It is Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether rstack, then there is dot, and it ends with com. On the main page, like you are going to see an article, gas station model versus parking lot model, and the article describes in very, very big details about the type of product that we're making and its specific features and uses. And also the main page contains 3 different surveys which you can fill and tell us about your needs of charging products so that we could modify an existing product to fit your needs, or we can build custom products for your needs as well. And with this said, I'm ending talking about this project, and I like to mention the next project that we have just released. It is has built artificial intelligence agents, and this specific project, the purpose of this project is about entering a new category of entertainment and just for fun. And this project has currently two different artificial intelligence entities, and each one of these entities is outfitted with their own gender, their own voice, their own avatar, and their own large language model. And like you, the user could request specific interaction, and then this interaction could start, and you can observe this interaction between one entity and the other entity going back and forth with this interaction. With this said, I like to tell you the name and the URL of this website. It is ai2ai.decentralizedweb.org. AI to AI is typed in the way of the letter A followed by the letter I, followed by the number 2, and followed by two other letters A and I. And it is all together AI to AI. Then there is dot, then there are two words, decentralized and web. They're typed all together, and then there is dot, and it ends with org. Once again, AI to AI dot decentralizedweb.org. One example of interaction between two AI entities is that let's say the first AI entity is outfitted with a female gender, female avatar, female voice, and specific pitch for this voice. And you request this AI entity, you have the initial prompt for this AI entity to be very seductive. And you have a second AI entity, which is outfitted with a male gender, male voice, and specific pitch of the voice, and their own male avatar as well. And then you can request this second AI entity to be very angry. And when you start this interaction, then you're going to observe the first female AI entity trying to seduce the second male AI entity, and then the male AI entity is responding in an angry fashion to the first AI entity. And with this said, I like to invite you to try this project. There's initial credit which you can use to evaluate and enjoy the interaction, and then you can decide to refill your account and continue enjoying interactions between AI entities. With this said, I'm going to the last project that we're currently working on, and this project is in very early stages, and it builds something which resembles an announcement by OpenAI company called Atlas Browser. With Atlas Browser, you have a program which is looking at your interactions and what you type in the browser, and then it is recording these interactions. In our project, we consider that we do not need to build the whole browser, but we have to build a technology which could record interactions done in a browser, but not only in a browser. It also includes interactions done in normal programs in a computer or mobile device or tablet. And then after recording these interactions, you can label a specific interaction, and then by calling this label, we are going to automate a specific interaction. So what an interaction could be is, for example, looking to buy one or more food items from a grocery store, or ordering a ticket for an event like a concert or a movie from a website, or like searching for a flight at a specific range of days and times from either the website of airline company, or from like a website which aggregates inputs from multiple airlines and then gives you the results back. With this said, I'm going to end talking about our project. Thank you for listening. Thank you for viewing. Have a nice day, have a nice evening, and goodbye.